Hello, students. How are you? So, we are going to begin talking about graphing all polynomial functions. And when we're going to generalize into the others, but today we're going to review what you already know about graphing one of the simpler kinds of polynomial functions, quadratic functions. So this was a big focus last year. So let me review with you the types of quadratic equations that you'll get and how we look at those. So we have standard form, and that is y equals ax squared plus bx plus c. We have vertex form, and that is y equals a times x minus h squared plus k. Those are the two you probably worked with most. We also have factored form. Here, I'll make them all three caps. How about that? Factored form is y equals a times a factor, and we'll say x minus, x minus r sub 1 for root sub 1 times x minus r sub 2 for root sub 2. And sometimes these forms sort of overlap each other, but I want to mention to you, you see an a in all of these. The a always plays the same role. So a is going to tell you if the parabola is up or down, if it's normal, if it's tall and skinny, or if it's short and fat. Okay? So the a kind of gets into the shape of the parabola. Now all three forms have something easy about them. So if I talk about the easy thing, then I'm going to say standard form makes it easy to see the Y-intercept because it's going to be the C value. All right, so the Y-intercept will just be 0C. But the other parts of the parabola that are really super important, the vertex and the X intercepts, are not so easy to see. Now, vertex form is my favorite because it makes it easy to see the vertex. And the vertex is the most important point on the parabola. So if you look at x minus h squared, it's telling you that positive h, and then at k, comma k, is your vertex. So all of them have something easy. Now the thing that factored form makes easy to see is the x-intercepts, or the roots, or the zeros, or the solutions, but I'm just reminding you of different things that we call the same part of a function or a graph. So the roots would be at x equals r sub 1 and r sub 2. So all three forms are helpful in different ways. So what we're going to do is we're going to just take a minute and let's do the most important part of each parabola. Let's name the form of the equation, tell whether the equation's up or down, and we'll figure out how to find the vertex. So we will do this in our first video. So if you will look with me on your skeleton notes, it will be easier for you to follow along. So do you see that this first one is in the form y equals a times x minus h squared plus k? That means we are in vertex form. That means finding the vertex is going to be super duper easy. I love this. Can you tell that since the a value is positive 2, that means the parabola opens up? Now I'm not going over as much description as I would have last year because I think when we do the problems that you ought to start remembering what you did last year. So vertex form is super easy for the vertex, so say v equals, and then you need a point. So from vertex form, I don't need to do work, I can just name the point. So I can see that x plus 1 squared tells me negative 1's my x coordinate, you flip-flop the sign, And then 5 tells me 5 is my y-coordinate. So on the x, it's always the opposite since it's inside the parentheses. But on the y part, it's exactly what it says it is. Now, go to number 2. On this one, do you see it's in y equals ax squared plus bx plus c form? So that is standard form. Now, I can, whoa, that's a bad D. Sorry about that. So I can tell that the a value is 3, which again tells me my parabola is up. Okay? Now, the vertex in standard form is not as easy to get. So what I have to do is say x equals negative b all over 2a. I bet you remember that now that you're saying it. So negative b is negative 24. 2a would be 2 times 3 or 6. And that's giving me negative 4. So remember, for any equation, if you have an x, you plug in to get y. So I'm going to say y equals 3 times negative 4 squared would be 16 plus 24 times negative 4 plus 48. And you might be saying, we're supposed to do this without a calculator? What I really mean by that is don't rely on your calculator to do the work for you or give me a bunch of decimals. So I know that this is 48. 24 times negative 4 is negative 96. And then plus 48. So I believe that's equal to 0. 48 times 2 is 96. Yeah, I double checked. So now I know that the vertex is my x-coordinate, comma, my y-coordinate. So say v equals and label your work. Now let's go to problem 3. So do you see that this is in the form y equals a times x minus r sub 1 times x minus r sub 2? Therefore, you can see that this is factored form. Now, is the parabola up or down? Well, I see that the a value is negative 1/3, so the parabola opens down. Now, there's different ways to do this, but here's what you need to know. I'm going to do kind of a sketch already, and I think it'll help you see this, because you wouldn't have focused on this one as much last year. But here's what the deal is, guys. All right, I'm going to name the X intercepts as I go. If I were to set the equation equal to 0 in order to find the X intercepts, so set it equal to 0 instead of setting it equal to y if you want the roots or the zeros as solutions. Do you see that the factors tell me x equals negative 12 and x equals 6, and those are the X intercepts. So in other words, negative 12 comma 0 and 6 comma 0 are points on the graph. So let me erase this. I'm going to make some more room to move to the left. So when I look at it, oh, I changed colors. I didn't realize I did. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there's one root. And then I've got 1, 2, 3, 4, 5, 6. There's another root. Now my parabola opens upside down. I don't know exactly how high the vertex goes, but look, what I can do is count. And see if you can follow me on this. If I count from one root to another, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. 18 total spaces between. The vertex has to be right in the middle. So if you have 18, that's 9. So count from either vertex inward 9. So now I'm going to count 1, 2, 3, 4, 5, 6, 7, 8, 9. So my axis of symmetry is here. So what I know, and I will actually do a better job here when I do a little bit more with this, but I know that my vertex is going to have to be along that dotted vertical line. So the parabola has to open up. I don't know how tall to go with it yet. But guys, that tells me that the vertex is, let's see here at 1, 2, 3, I'm seeing that I put that vertical line through x equals -3. And you might be going, what? So guys, if you know the x coordinates of your x-intercepts, which you do from the factored form immediately, you want to go in the middle. Well, in the middle means that you're just averaging your x's. So you add them up and divide by 2. That's -6 divided by 2, and that's where I got the -3, okay? So you just have to know what it is you're looking at, and then how you get the vertex is probably going to make more common sense to you. So then remember, anytime you have an x, if you want the y, you plug in your x. So I'm going to say y equals -1/3 times x, which is -3 plus 12, times x, which is -3 minus 6. So I'm plugging into the black equation that I gave you in the upper left-hand corner. So y equals -1/3. 12 minus 3 is 9. -3 minus 6 is -9. I can say that's -1/3 of -81, because this is your -81. Negative times a negative is a positive, and 1/3 of 81 is 27. 81 divided by 3 and 1/3 of 81 are the same dill pickles. So the vertex is at -3, 27. Now you might go, what? If you look at this, see how I went ahead and drew this point up here? What I'm going to do is I'm going to mark on the number line, because I am not honestly going to tick mark all the way up to 27. So I'm going to mark right there that that's 27. And then I know that the parabola opens evenly or symmetrically on either side of the axis of symmetry. And the axis of, boy, I didn't get that straight. Sorry, that's part computer fault. But the axis of symmetry runs from the vertex down through an upside down parabola, or an axis of symmetry runs from the vertex up through a right side up parabola. So I've done a lot of the work on this one already. I'll come back to it, however. So on this one, are you seeing that it is in the form y equals a times x minus h squared plus k, meaning vertex form? Yep, yep. This is my favorite one for sure. Are you seeing that the a is -4, and since it's negative, the parabola is upside down? Are you reading the vertex super duper easily? That x minus 3 tells you that it's 3 comma, the 7 tells you it's 3 comma 7. I'm going to the next problem. We've got 6 total. On this one, can you see it's in the form y equals ax squared plus bx plus c? And that is standard form. Are you seeing that the a is positive 1/2, so it opens up? Okay, so once again, standard form makes the vertex really not so easy to spot. So from standard form, you say x equals -b all over 2a. So you've got to memorize that that's the vertex formula for the x when you're in standard form. So you'll have to know to apply that formula. Well, -b in this case is +8, and 2a is 2 times 1/2, which is just 1. Well, at least that worked out okay. Now, if anytime I have an x, I plug in and I get the corresponding y. So I have half of 8 squared. I can go ahead and do 8 squared. Minus 8 times 8, I'll go ahead and do that, plus 27. Now, half of 64 right here is 32. So guys, I know that 32 minus 64 is -32, and -32 plus 27 is -5. So I'm going to wrap it up and say v equals 8 -5. So let's do the last problem, and that is to look at this one. Now, let me say that you can look at this one 2 different ways. I'm going to write this and then I'll erase it. I could look at it as negative 1/5, and I could think to myself that x minus 10 squared means x minus 10, x minus 10. If I look at it that way, I'm thinking it's in factored form. Or I could look at it and say it's y equals negative 1/5 x minus 10 squared, and if I added a plus 0 on the end, it looks more like vertex form. So sometimes the forms might kind of cross over. And so if it were me, I would just look at this like it's in vertex form, because I think that vertex form, again, is a little easier to manage. But I tell you what, let's do this. If you look at it as if it's in factored form, do you see that you've got a root at 10 and a root at 10? That means x equals 10 is a double root. Okay, and we'll talk about what that looks like. And if you look at it as if it's in vertex form, are you tuning into the fact that the vertex is at 10, comma, 0? Okay, so wait a minute. How do you piece that together? Well, let's see here. 10, comma, 0. And the thing opens, it's negative 1/5, so the thing opens down. But look, I'm going to say 10, comma, 0. I'm going high with my x-axis since this puppy opens down. 4, 5, 6, 7, 8, 9, 10. So your axis of symmetry is there. So look, that means that 10, comma, 0 is here. That's both the x-intercept. So if you've got a double root, remember, then that means that the graph doesn't cross the x-axis, it sits or hangs on. So I'm going to say the graph kisses the x-axis. At a double root. Because this is also the vertex. So if your x-intercepts and your vertex are one and the same, then the parabola is either just going to sit on top of the x-axis, or it's going to hang onto the x-axis. So I know that the graph opens down from there. I'm going to dot it in because I haven't done enough work to figure out exactly how wide to make it. All right, so while we're here, let's just work backward through the y-intercept, because the y-intercept is easy, and then we'll talk better about graphs and x-intercepts. So this one is going to have, if ever you want a y-intercept, you simply plug in 0 for x. So plug in 0 for x. And it doesn't matter, plug in 0 for x. It does not matter what kind of an equation is. You always plug in 0 for x to find the y-intercept. So in this one, you'd say y equals negative 1/5 0 minus 10 squared. That is negative 1/5. You know 0 minus 10 is negative 10, but if I square negative 10, I get 100. And negative 1/5 of 100 means divide 100 by 5. That's 20, and it's negative. So the y-intercept is at 0, negative 20. Guys, I'm not going to tick mark all the way down to negative 20. So on this one, it makes sense to me that if I were to keep graphing all the way down, that my y-intercept is going to be so low it runs off the screen. Okay? So we'll come back and talk a little bit more about that. But right now, you've got enough that I can kind of get a decent looking graph. And we'll talk more about x-intercepts and so forth that will help us shape our graphs really well. Now, on this one, the y-intercept is going to be easy because remember, you plug in 0 for x, so it's 1/2 times 0 squared minus 8 times 0 plus 27. Well, guys, that's just 0 plus 0 plus 27, right? So y equals 27. Remember, we said in standard form, when you look at the C part, that is your y-intercept. So standard form makes y-intercept easy to spot. Again, 0.27 is going to be really, really tall, so I may not totally put it on the graph. I might expect that it's going to be so tall that my graph kind of runs off the screen before I got to it if I were doing tick marks. So y-intercept on this one, I'm going to plug in 0 for x, is going to be 0 minus 3 squared plus 7. Well, that's negative 4 times. 0 minus 3 is negative 3, but when I square it, I get 9. So that's going to give me negative 4 times 9 is negative 36 plus 7. And when I say negative 36 plus 7, I get negative 29. Goodness gracious, we've got some out-of-sight big y-intercepts. So again, that might be another one that runs off the screen before I'm able to plot it. And we'll talk about that, okay? How I'm going to deal with that. So on this one, if I say, well, let me plug in 0 for x, I've got 0 plus 12. I've got an extra comma in there. I don't know why I did that. Been a long day maybe, I don't know. Times 0 minus 6. So y equals negative 1/3 times 12 times negative 6. Tell you what, 3 goes into 12 4 times, so that's the same thing as saying negative 4 times negative 6. So that's positive 24. Again, a big y-intercept. Now, let me show you something. Remember, we said this vertex was at negative 327. And look, this thing is hitting the y-axis lower than the vertex, so does it surprise you that that tick mark could be 24? So we're actually totally done on this one. That's cool. Now on this one, again, now I'm used to this as standard form, so I know the vertex is easy peasy because it would be 0 plus 0 plus 48. I don't need anything else. So again, 0.48 is like a huge y-intercept, so I may not show it on the graph. And you know, I'm going to ask you to put 3 points on your graphs. And so if the y-intercept is way too big to put on your graph, that's not what you want to use. So here we go again. I'm going to plug 0 in for x. So 2 times 0 plus 1 squared plus 5. Of course, 0 plus 1 is 1. Squared is 1 times 2. So it just comes down to 2 plus 5 is 7. Now plotting the point 0.07 then would be reasonable. Okay? So in the next video, we will come back and talk about finding the x-intercepts and what you need to do to get a decent 3-point sketch of your parabola.